back. This is A-Level Computer Science 9618 paper 4, and today this is my first video, and I will start from low-level languages and declarative language. Okay, so let me just show you the syllabus of the whole computer science before. This is the syllabus. You got these data structures like linear search, binary search, insertion sort, bubble sort, linked list, binary stack, queue, dictionary graphs, big notation, space and time complexity, and then you got recursion. In here it's all about the structure. For example, OOP is a structure, object oriented programming. You got class and objects. Declarative language, low level languages, procedural languages, file and exception handling. For now I will start from low level language and declarative language. Then in the next video I'll discuss about OOP, and in the third I'll discuss about filing, and then or maybe filing and exception handling at the same time. Procedural language is covered in P2 in paper 2. You can just watch the video. Procedural language is what is procedural language? It's a language which means it's more like procedural, you know, having so many functions and methods, loop, while loop, do while loop, all the stuff without any OOP involved, without any object oriented programming involved. Okay, so it's filled with objects and it's filled I'm sorry, not object, it's filled with methods and procedures. Okay, you are using function and procedures without any OOP. So that's procedural language. Okay, so let's start from low level language and declarative language. Okay, the assembly language was discussed in P1. So you can just, if you want to revise this, so you can just watch the video, because I've already covered this in P1. Like we have these instructions, and they have different categories like data movement. If you want to do data movement, you will use this instruction. If you want to do arithmetic operation, you will use this instruction. Doing any kind of comparison or jump, like if then else, the condition is quite similar to conditional statement, you will use these instructions and input and output using these. All right, we know about assembly language, we know about machine code, we know different form of addressing. Let's come, this is a question from P1 which we already solved this. So P4 start from here. Everything is literally the same. We all know what each and everything is, except for these two are new. And masking also, masking also is also coming, but don't worry, I've already discussed in P1, so just check the video. First of all start with what is LSR and LSL. LSR is used for division. Like for example, you just write LDX number, which means address plus index register, calculator address, then you just take the content from that calculator address and put into the accumulator. Done. Then LSR, this 3, which means you are dividing the whatever the value it is stored in the accumulator, you're just dividing by the number of the 2 of power n, 2 of power 3. Okay, if it is written 3, then 2 of power 3, 8, divide by 8. If it is written 2 of power 4, if it is written 4, 5, 6, then 2 of power 4, 2 of power 5, 2 of power 6. Okay, like this. And then STX means that the address plus index register become the address, using the address to find the content, and then actually address plus index register, and address plus index register, it becomes the address, and then taking out the content from the accumulator and storing to that calculator address is known as STX numbers. Okay, you can just check the description yourselves because it's the same definition. And from address, which is numbers plus the content of the index register, copy the content from accumulator to this calculator address. The thing is, I just want to tell you about what is LSR. Everything else is just written. Whenever you're going to give the paper, you'll see this whole list of instruction, and then using this instruction to do what you have been told. Okay, so if you guys understood about LSR, then we will just move on ahead. LSL is used for multiplication. For example, you've been said that load the value from numbers, multiply by 4 and store the new value in the calculator address. Multiply by 4, which means 2 of power 2 is 4. So you just calculate the value, something. Calculate the content of the accumulator by this number 4, and then store it into the different address. LSL is used for multiplication. LSR is used for division. Okay, we understood that. Now, moving on ahead. So this is quite complex. It's like, for example, if we want to assign a value, like we have the variable a and we want to assign a variable 34. In assembly language, we are going to write down this way: LDM there's 34, and STOA, which means store in a. LDM 34, which means that you're storing into the accumulator directly. LDM, load the number into accumulator, okay, and then you're just storing it. This is how you write it down in assembly language, and this is how you write down in high level language, in Java, in Visual Basic, in C Sharp, in Python. This is how you write it down, and this is how you write down in assembly language. So you can just see that how there's a connection. This is how you represent it. B is equal to b plus 1. B is a variable. You're trying to increment it. So what you will do, LDDB, which means that LDD means load the content of the location. Load the contents of the location at the given address to accumulator. Okay, you're just storing it into the accumulator, which means that you are storing in the accumulator directly. LDD means that you are storing the value from B into the accumulator, and then inc accumulator, which increment accumulator, and then storing it back to B. Here's what's happening. The value of B, suppose, is 1. You have the accumulator LDDB, which means you're taking it out and putting it into the accumulator. Then inc accumulator means that accumulator is incremented by 1, which means 2. Then STOB, which means now you're putting it back into B column. So now it's become B. The value of B is 2. So this is how you're trying to write down the code. Okay. Input A in STOA. It's very easy, literally. You will see this. Okay. So let's do this question. Start loop 1, and you need to do this, all of this. Let's start from here. Initialize index register to 0. Okay, so we need to initialize it. How am I going to do that? Initialize the index register to 0. Okay, there you go. Load the number app and do index register. You are saving it. Move the, okay. So I'm going to use LDR. Okay. So I'm going to use LDR, and I'm going to say it's 0. This is the operand. Why did we use this symbol? We use it because it's a ternary number. Okay, that's why we used it. Now initialize count to 0. Initialize count to 0, which means that you are, okay, so I'm going to use, let's see, load the number into the accumulator, LDM. Or is there any other way? Accumulator. Okay, move the column. Okay. Yeah. Load the number n into accumulator. So LDM. I'm going to write down LDM 0. And then I'm going to write down. Now I need to transfer from accumulator to the count variable. Okay. So I'll use LDD. So LDD. Okay. Wait. I might use LDD. Load the content of the location of the given address. Oh, sorry. I want to from accumulator to somewhere. So store the content of accumulator at the given address. So I will use STO. STO count. Count is a variable which is It's a label which is written here. Okay. Now it's loop start. Load character from index register index address name. So name is the address label. It's a label actually, and you need to load character from this variable. Loading a character. It's talking about a character. So if I want to load a character, okay, since it's talk about index address, it's talking about, we just, it says load character from indexed address, indexed, which means if it is talking about index, this index addressing. No, form the address from address plus the content of the index register. Copy the content of this calculated address to the accumulator. If I do that, okay, I have been asked to store it. Load character from this, right? So I'm going to save it into the accumulator. So I'm going to use LDX. Output character to screen. If I want to output it, so I'm going to use out. Output character to screen. So what will it do? Output to the screen the character whose ASCII value is stored in the accumulator. Okay. So I'm just giving an output, whatever it is stored in the accumulator. So right now we have just load the character into the accumulator, and then we just run the out instruction. Then increment index register. Now I need to increment it. Okay. So in order to increment this, I need to increment it, right? Increment. Add 1 to the corner of the register. So let's increment it. So I and C, and then you just choose anyone. Index register. Wait, index register. Increment count starts here. Increment count starts here. Now what does that even mean? Which means that you need to increment the count. Okay, so I will write down count. Increment count starts here. First of all, I'm going to take the value from count into the accumulator. I will increment the accumulator and then put it back into the count. This is how I'm going to do it. So taking it, load the count at the unit to accumulator. I will use LDD. Okay. So LDD. I will try to increment this. So I'm going to increment the accumulator, and then I'm going to put it back by using STO, store into the count again. Okay, from accumulator to count. Then is count is equals to max. Now I need to make a comparison. How to do the comparison? Compare the content of the accumulator with the content of the address. Compare the content with the number. Okay. Right now I'm comparing with an address, and I mean by address means the labels having address. Okay, so I am doing comparison, so I will use this CMP address. If false, jump to loop 1. If it is false, jump to loop 1. Okay. If compare was false, I'll use this JPN and using the address JPN, and then I'm going to use loop 1. It will jump to loop 1 if the condition is false. Reverse decrement index register. Right here, just increment index register. I'm going to decrement. So I'm going to use DEC index register. Set accumulator to 0. Okay. Set accumulator to 0, which means that I'm going to use I need to set accumulator to 0. So how should I do this? Let's see here. Initialize count to 0. Set accumulator to 0. Initialize count to 0. Load the number into accumulator. Okay, I'll use this and LDM. LDM 0. Store in the count. Okay, so I'll just use STO then. STO count. Load character from index register, index address name. Load character from this. Same thing happening here. Load character from this. So I'll use again LDX name. Output character to screen. So I will use out. Same thing I've done in here, out. Decrement index register. So I'm going to decrement using DEC. Increment count starts here. I think I'm going to just copy and paste. Same thing in here. Count. Okay, I'm just going to copy this. Wait. Let's copy. Or wait, let me just log this and then I'm going to copy again. Okay, put in here. There you go. All right, LDD increment STO count. Then you need to compare it again. So I'm going to compare using CMP address. Again, the same thing. CMP, what was it? CMP max. If false, jump to loop 2, which means I'll use JPN and loop 2. End of program, I'll use end. Then this is it. Alright, so the value of the count is, what did you do? Initialize count to 0 and then increment count starts here. Okay, 1 increment is count is equal to max. Okay, is count is equal to max, if false, jump to loop 2, end of program. Okay, so which means count is equal to max and it is 4. So this is how you do low level language. This is how you will get the questions like in this way, and then you will be given this list of instruction and then using these to make the program. Okay, so this is your low level languages. The declarative language, let's start from there. What is a declarative language? It's all about facts and figure. It's telling you, you're telling the machine that what is a fact, what is fact and what are the figures. What are the facts, actual facts that the machine need to understand. That what is the capital city of Paris? Is Paris a capital city? Is London a capital city? If it is, then it will return true. If it is not, it will return false. You're using these to ask the machine. Okay, this slash and then capitals, this and this sign, capital city, and then asking it. Okay, you will be given the question like in this way. A declarative programming language is used to represent the knowledge base shown below. This is programming. Capital city is this, capital city is Beijing. You're just writing it down. You're just telling the computer that this is the capital city, that this is the capital city, these are the capital cities, and this the city in country, that this is the city in this country, city in this country, city in this country, in this country, so forth, so on. City visited, You're just telling the computer that what are the facts. Okay. After telling the computer, you can just ask questions like these. This is a way of asking the questions. So you might be given the question like in this way, and then you will be given, like for example, you need to convert this, you know, more facts are to be included. Okay. The travel writer visited the city of Santiago, which is the capital city of China or Chile, in the continent of South America. Write additional cloth to record this. Oh, this format, I guess. So I'll write down this in here. Okay. Okay. With the city of Santiago. Santiago is a okay. Santiago is a capital city. So I'll write it down. Capital city. Santiago. Okay. Copy this. Paste in here. Okay. Is a city in the country of Jordan. Is a capital city of Chile. Okay. City in a country. So write down in this way. City in country. So write it down. Santiago, Chile. Okay. Okay. Is a country in the continent of Europe, in the continent of South America. Okay. Chile is in the continent of South America. So country and continent, I'll write down country and continent. Country in continent and Chile, South America. Chile, South America. Okay. Okay, so this is how you're going to write down in this format. So you have just written down the facts. More facts are to be included. I have just included it. Okay. Then you might get these kind of questions. How big is this? And I don't think it's not that big. No, it's not that big. Okay. So this is how you write down facts. After writing down the fact, if you want to ask question, then you just write down this one. And is Paris is a capital city? Yes. Is London is a capital city? No, false. Country visited this country. Okay. Let's start from part B. Using the variable this country, the goal. Country and continent, this country, Europe. Okay, hold on a minute. Now let's just observe this. This is a variable. It's not something like I've just declared that this, this is a variable. And I've used this variable and I just put it in here. So what am I doing? I'm just trying to find a query. I'm asking the machine. I'm asking the machine that tell me the name of a country which are in Europe. Okay, so then it will tell that the name of the country is Belgium, UK, etc., etc. So this is a variable. This is how you try to take out, get the facts. After telling the machine that this is a country of this is a continent of this is a capital city, that this is a capital city, and that capital city in this. So after telling it, now you are asking questions. Now you are just doing some query. Okay, you just use this variable, you put it in here, and then you just asking the machine that what are the tell me the number of countries which are in Europe. Country in continent, this country which is a variable, and Europe which is a continent. So it's telling us that the country is would be Belgium, UK, which are found in Europe, and we just already declared this in here, like UK is a country in Europe, Belgium it is in Europe. Okay, so this is how you try to do some query. Now you've been asked that write the result returned by the goal. So you call this a goal. Okay, just call this a goal. Okay, city in country, this city is the variable UK. So what will it return? Now let's see the UK. It said this city UK. Okay, so it's written here, it's written here. So the answer would be London, Manchester. This would be the answer, London, Manchester. Okay, this would be the answer. Another question, complete the rule below to list the continent. Complete the rule below to list the countries the travel writer has visited. So we are actually trying to create a rule that country visited this country if, and now we're just creating this new rule. Okay, so this is a rule, a goal that we wanted to create. It's like a function that we are just creating a function, then we just write down the code. Okay, so country visited this country if what, let me use from here, if that country visited this, if the city visited, okay, this country, right? List the country the traveler writer has visited. If this, let me just say that city visited this city. Let me write down this way, city visited this city. Okay, and this city is in this country, city in country, city in country. City visited this city. Okay, and city in country, this city is in this country. Then only then it will work. This is the whole stuff. So this would be the answer. Okay, country visited this country if the city visited this city and this city is in this country. Only then this rule will apply. So we have created the rule by writing down this. So this is how declarative language works. And country visitors if cities visited Y and city in country Y this country. Yeah, I have just written down the answer in here, but anyway, this is how it works. Grandparent is, G is a grandparent of S if parent G is a parent of P and P is a parent of S. So this is another example that grandparent, like G is a grandparent of S if G is a parent of P and P is a parent of S. So indirectly G becomes the grandparent of S. In Prolog SW1, this is the software that in the right now I'm just writing down the syntax, but in the software you will write down like this, that grandparent, and we use this symbol denote as if, and then using this comma denote as end. Okay, So in prologue we'll just write down here, but don't worry about it. We will I think the paper will come in this way, in this form. Okay, in this form you just write down in simple like this way. So don't worry, just to remind you that it's written, it can be written in here in like this, using in the prologue. Okay, sibling. A is a sibling of B, is parent. P is a parent of A, P is a parent of B, and A is not equal to P. Okay, this is again in prologue. This denote if this is and, this is and. Okay, contains meat if ingredient X is a is a meat. Okay, and I don't know why I did put slash, but X is a meat, and okay, contains meat. X contains meat if X is a meat, and I don't know why I write down. It seems to me I'm just doing a query or something. Forget this example. For now, I hope you just understand that this is how you write down. Okay, recursion. In the declarative language, we have recursion as well. How do you write recursion? For example, we need to find that ancestor A is the ancestor of B. If A is the ancestor of B, if A is a parent of B, B is a parent of, I mean, B is a is a parent of X, and X is an ancestor of B. You just call it back. Okay, this is how you're doing recursion. Just call it back. Okay, this is the base case. This is how you just breaking down. This is the base case, and this is the general case. If you have been asked about write down the recursion, you will just write down in this way. You will tell them, you're going to write down that what is the base case. This is the base case. A is the ancestor of B if A is a parent of B. The base case, the last point that will come when the recursion will come to the bottom line. This would be the base case that it will meet. Okay, but this is the general case. This is how you write down recursion. Okay, list is in data structure, but let me just discuss this right here. It does come into declarative language. We do use this. Okay, sometimes. How do we use it? H/T slash means that you're having a list others, and H means that you have only one in here, and then /T, which means you have others. So car slash others, this is known as other list. This is one. The first element, the list consisting of remaining list elements. This denotes an empty list. And that's it. I think it's enough. In the next video we'll start from OOP. Okay, for now, thank you so much for watching. Goodbye.